Here are some reminders to help you get the most out of your DIVES CD lessons. First, work the problems with me. Work every single problem that I work and take notes on everything that I write on the board. One thing I encourage you to do is on the first practice problem, work that one with me, but then for the second and subsequent ones, pause the CD, try to work the problem on your own, then fast forward to the answer. If you got it right, great, you can move on to the next one. If you got it wrong, rewind the CD, look at how to solve the problem, and figure out how to do it correctly. Next, anytime you need to, pause and rewind the CD until you understand that particular concept. The ability to pause and rewind so easily is what makes DIVES CD lessons so much better than a live classroom lecture, so make sure and take advantage of that technology. Next, remember the purpose of math is to teach you to think and to solve problems, to effectively and efficiently think and solve problems. In the lower math levels, there's lots of mental math. In the upper levels especially, this is the most important purpose of math, is to teach you to think and to solve problems. Next, do all of the problems in the problem sets. It depends on the course that you're doing, but typically you'll do 3 to 5 problem sets a week, so that means 3 to 5 CD lessons plus a test. Next, work the homework problems and your test problems too. Work those vertically. Split your paper in two and work them vertically. And of course, make sure you show your work on your problems too. As you work them vertically, write each step down and write each subsequent step underneath the previous one. And this will help you sometimes to recognize patterns a little bit easier and help you solve the problem better. Also, use a calculator sparingly, only for geometry problems and some word problems. Don't use it for Math 7-6 or below that for any of that. Algebra half and up, use it sparingly. And lastly, have a good attitude. Every day you do school, you have a choice to make. It is your personal choice to have a good attitude, work hard, do your best, or to be lazy, complain, whine, and have a bad attitude. So choose right now to have a good attitude. Dive in, take advantage of this CD lesson, and do your best to learn the math that you're going to learn today. Lesson 10 has several parts. The first part will be talking about division by zero. Then we'll talk about exchange of factors in multiplication. And then lastly, we'll discuss conversions of area. First, let's talk about division by zero. And a way to understand this is, let's just start with 6 divided by 1. And that equals 6. Now let's try a little bit smaller denominator. 6 divided by 0.1. That would equal 60. Now let's try 6 divided by 0.01. That would equal 600. And so I'm making my denominator smaller and smaller. And so you could understand then, as I got closer and closer to 0, the result of that division would get bigger and bigger and bigger. And so 6 divided by 0, that is equal to infinity. And we also just like to say that that is undefined. Anything divided by 0 is undefined. Likewise, if you just had 0 divided by 0, that's called indeterminate. It's just a special name for it. Instead of calling it undefined, we have 0 divided by 0. They say that that is indeterminate. So in this textbook, any number, non-zero number divided by 0, you'll just say that that answer is undefined. 0 divided by 0, you'll call that indeterminate. That's just the special word that's used for that type of a division. Now, if you had 0 over anything, like 0 over 2, that's like saying 0 halves or no halves. So anything, when 0 is the numerator, it's always equal to 0. And we could even represent that as 0 over x, where x represents all real numbers, positive, negative, except for 0, because 0 over 0 is indeterminate. So for all non-zero real numbers, 0 over x is always equal to 0. So just to get a little bit of practice with working with division by 0, let's look at practice problem A there, and let's do that one. Just solve that, simplify it. Negative 3 plus 1, we'll do the numerator first. Negative 3 plus 1 is negative 2. And then on the denominator we have negative 7 plus 11 would be 4, minus 4 would be 0. So we have negative 2 over 0, and so that, for our answer, we'll just say that that is undefined, because it's a non-zero number divided by 0. So that's undefined. Let's do one more. Simplify this, so let's do the numerator first, then the denominator. And we have negative 4 times 0. Well, we know that any number times 0 is just 0. And we don't put a sign in front of that, even though it's looks like a positive times a negative. Remember, 0 is not positive or negative, so we just call it 0. And then on the bottom we have 4 plus a negative 3, so that would give us positive 1, plus a negative 1, that would be 0. So we have 0 over 0, and so the answer there, we would say that that is indeterminate. So any non-zero number over 0, we call that undefined, and then 0 over 0, we call that indeterminate. Let's go on to the next section. This section is about exchange of factors in multiplication, and basically what they want to explain here is the commutative property of multiplication and how that applies to signed numbers. And say, for example, you had 4 times a negative 3. The commutative property says that order doesn't matter in multiplication, and it's the same with signed numbers. That's all they want to explain here. So negative 3 times 4, that's the same thing as 4 times negative 3. So if you think about it in terms of the concept of opposites, you can say the 4 times the opposite of 3, that would be negative 12, or like on the bottom one, you could say the opposite of 3 times 4, that would be negative 12 again. So let's do some practice problems. Look at practice problem C, and let's just multiply pairs of numbers. And just like we learned in lesson 9 about like signs yield positive results, unlike signs yield negative results. So we'll work in pairs here. Negative 2 times negative 5. Let's do that operation first, and that would give us a positive 10, and then bring the negative 3 back in there. And so now we have 10 times negative 3, that would be a negative 30. So the way I did this problem, I think that is helpful in eliminating errors, because I just wrote the problem out vertically, and I did this operation here that I just circled in red. That's that positive 10 right there. And then I just brought down the next factor that I hadn't worked with yet, the negative 3. And so I kind of keep everything in line there, and that helps keep it organized and helps me keep up with my signs. That's usually the most important thing on these problems. They're not really that hard. It's just you forget to keep up with signs, and then you miss them. You get positive 30 instead of negative 30. Let's do another one. And again, just multiply in pairs. And so at the beginning there, we see we have the opposite of 5, or negative times negative 5. Anytime you have a negative sign outside parentheses, you can think multiplication, because that's what that parentheses is indicating there. Negative times negative 5, so that would be a positive 5. And then we can go ahead and do the next pair, 2 times negative 4. That would be a negative 8. Okay, so now we can just do that multiplication, and that would be a negative 40. So the order that we do those doesn't matter. We could have done 2 times negative 4 first, but usually I just like to work left to right, multiplying in pairs as I go. Let's look at the next section on area conversions. In lesson 4, we talked about unit multipliers, and we talked about how important those are, especially in sciences and engineering, because you're always working with units, and you may need to convert from one unit to another. Area conversions are a little more complicated than just a basic length conversion. You just have to remember, like in lesson 8, we learned that area has units of length squared. So it's like a length times another length. You're always multiplying two lengths together. So if you want to convert from one unit of length to another, you need two conversion factors or two unit multipliers. And they'll be the same unit multiplier. You just repeat the same unit multiplier twice in order to get the right conversion of units. Let's just go ahead and do some practice problems on this. Practice problem E says to convert 50 feet squared, or 50 square feet, to square inches. So if you remember, when you're doing conversions, just like conversions of length, the first thing you do on an area conversion or any conversion of units is to write down what's given. So we'll say 50 feet squared. And then we need to think about what we're converting to. So we need to convert from feet to inches. So we think, how would we do that? Well, 12 inches equals 1 foot, so we can use that conversion factor. And so we'll say 12 inches divided by 1 foot. Now, since it's feet squared, think about that. Let's just change that feet squared. We'll erase the exponent of 2 there, and we'll put feet times feet, because that's the same thing, right? Feet squared is the same thing as feet times feet. So we've got that one unit multiplier there, 12 inches over 1 foot. Only one of those feet cancels in the 50 square feet. So we've got to multiply by another identical conversion factor, 12 inches over 1 foot. You just do it twice. That's always what you do in area conversions, is you repeat the same unit multiplier twice. And so now we can cancel that second factor of feet. And so now we have inches times inches as our result. That's what we wanted, was square inches. And so we'll write our result, 50 times 12 times 12, inches times inches, or just inches squared. So just like inches times inches equals 6 inches squared, 12 times 12 is equal to 12 squared. So we could also write this answer 50 times 12 squared inches squared. So there's a couple of ways we can do our answer. Either way is correct. Look at practice problem F. Convert 1,000 feet squared to square miles. So like always on a conversion problem, we write down what's given first, 1,000 feet squared, and we can write that out feet times feet to help us remember to cancel all of our units. And then we need to think about what we're converting to. We're converting to miles. And we know that there's 5,280 feet in a mile, so that's the conversion factor or unit multiplier that we'll use. And so we need to make sure and do this correctly. The miles will go on top. 1 mile over 5,280 feet. Write out your number part and your units part. And let's go ahead and cancel. We can cancel one of our feet. So we still need one more foot to go here to cancel. So we just multiply by an identical unit multiplier. And so our feet, our second one, cancels there. And so we're left with miles squared for our units. Miles times miles. We see it right there in the problem. And so let's go ahead and write the answer out. 1,000 divided by 5,280. And we're doing that twice. So we can just say 5,280, put it in parentheses, squared. And then our units, miles squared. So we don't worry about calculating the numerical part of that answer. That's not the most important thing here, and that's not how they'll have it written in the answer key. They'll have it written like this with just the factors that were involved in converting from feet squared to miles squared. Let's do one more. Convert 5 square meters to centimeters squared. Okay, so we write down what's given first. 5 meters squared. I'm not going to do the meters times meters. Hopefully you understand that you have to multiply by the same unit multiplier twice on area ones now. And so think about what you're converting to. meters squared to centimeters squared. And so you know that there's 100 centimeters in a meter. So there's your conversion factor. So you put 100 centimeters on top and then meters on the bottom. And do the other one, 100 centimeters over 1 meter. And so your meters times meter, that's meter squared, that cancels the meter squared in 5 meters squared. And you're left with centimeter times centimeters for your units. And so now do the multiplication. 5 times 100 times 100, or just 5 times 100 squared centimeters squared. And that's your answer. So in area conversions, make sure you always multiply by the same unit multiplier. Multiply it out twice to cancel those units of area. Okay, well that's all for lesson 10.